Hello. So in part two, we're going to start looking at the next section where we're actually going to factor out a greatest common factor from a polynomial. So let me go ahead and pull up a blank sheet first, just because I want to point out what we're actually doing and then go into the notes. So in the previous units, in Unit 1 and also in Unit 4, we talked about the distributive property. So the distributive property, we saw that if I have A times quantity P plus C, then I could distribute and multiply A times both terms inside the parentheses. So that gives us AB plus AC. Okay, we saw that in multiple instances. Anytime we distributed a monomial times a polynomial, we would do the distributive property. So for example, a throwback to last unit, if I had 3 times 2x minus 5, I would take the 3 and I would distribute the 3 to all of the terms in the parentheses, which would give us 6x minus 15. Now, that is using the distributive property in one direction. Now, when we factor, we are undoing multiplication. So we want to do the opposite. So instead of starting from this and going to the multiplied form, we want to do the reverse. We want to take this 6x minus 15 and we want to move backwards to find out what's the biggest thing I could pull out of all of the terms and undistribute. So it's taking something that looks like AB plus AC and recognizing that all the terms have a factor of A, and so I can pull out the A to give me A times quantity B plus C. So it's like the distributive property, the way we've been using it, we've been going in this direction. And now we're going to be going in the reverse direction. We're trying to find out what's the biggest thing I can pull out. Okay, so let's take a look at our notes and hop back in. So this box at the bottom of this page on the first page of your notes tells you that exact situation. The process of factoring out a GCF is the reverse process of multiplying polynomials. We are using the distributive property, but we're using it kind of backwards. Okay, so to factor out a greatest common factor, you identify the GCF of all the terms of the polynomial. So you find the GCF of their coefficients and of their variable parts. Then you write each term as the product of the GCF and another factor, and then you can use the distributive property in reverse to remove the GCF. Now, these are the steps from our textbook, okay? I'll be really honest, I do this slightly different, so I'll show you what the textbook says to do, but I'm also going to show you kind of how I think of it. Whichever way makes most sense to you, please use that way. So looking at our examples, we're told to factor out the GCF of the following. And we have 6x minus 14 for example A. So first thing we need to do is we need to find the GCF of the terms. So let me make my pen a little bit smaller. Okay, so we're going to find the GCF between 6x and 14. Now you could think of that as minus 14, that's fine. And we want to find out what's the biggest thing that they share in common. Well, their coefficients have a GCF of 2, and their variable parts aren't shared at all because the first term has an x, but the second term does not. Okay, so in this binomial, the greatest factor that both terms share is a 2, which means we could rewrite 6x as 2 times 3x. And we could write 14, so minus, instead of writing it as 14, we could write it as 2 times 7. And do you see how they both share a common factor of 2? That means we could undistribute it or pull it back out, giving us 2 times what will remain is the other parts of those products. So 3x minus 7. So that is following the process from the book. The way I think of it, and the way I will probably continue to show you, is I will do this. Let me clear my, actually I'm just gonna write in a tiny little bubble down here. So let me make my pen smaller again. So I have 6x minus 14. I determined that the GCF between those two is 2. And so I think of it as 2 is the thing I'm going to pull out. So I need to divide all of my terms by the 2, which will give me my 3x minus 7. Either way works. The way that the book explains it shows you kind of that distributive property in reverse situation happening. You can physically see that both of the factors, or both of the terms, shared a factor of 2, and then you could use distribution to pull it out. My method is saying, well, I know that they both share a greatest common factor of 2, so I'm going to divide out that 2 and pull it to the front using the distributive property. So it's definitely 2 ways to get to the same conclusion. So that is the first example. Now let's do a couple more. We're going to go ahead and do D. So D, we look at our terms. We have the polynomial 14f to the third plus 21f to the second plus 28f. So the GCF of those 3 terms turns out to be 7f, because the greatest common factor of their coefficients is a 7, and then they all have an f term or an f variable, and so their f variable, the lowest exponent on any of the f's in all of those terms, is to the first. So their GCF is 7f. So that is what is going to be pulled out. Now again, you could write each term as a product of 7f times kind of what would remain. Or you could just think of it as, I'm going to take 7f and divide it out of each term. So if I take the first term and divide it by 7f, that's going to leave me with 2f to the second. We're using our quotient rule from our laws of exponents with our f to the third divided by f. Then we take our next term and we divide it by 7f, so that's going to be plus 3f. And then our last term divided by 7f, and we get plus 4. So this is our factored form. We have factored out the GCF from that polynomial. Essentially, we've undone some distribution, okay, which is what factoring is in these situations. So looking at B, we have 20m to the third into the fourth plus 5m to the second into the second. And so I need to find their GCF. That's what I will pull out of all of the terms. Their greatest common factor is 5m to the second into the second. That's the greatest common factor of their coefficients and of the invariables and of the n variables. So I can pull out the 5m to the second into the second from each term. Remember, the way I think about it is I divide each term by the GCF, the thing that I'm pulling out. So, oh, okay. Wow, she got a little persnickety there. It like shrunk on me. So if I take 20m to the third into the fourth and I divide it by 5m to the second into the second, 20 divided by 5 will give me 4. m to the third divided by m to the second gives me m, and n to the fourth divided by n to the second gives me n to the second. Again, this is just simplifying a monomial, like dividing a monomial by a monomial, okay? Then for the second term, I'm dividing it by 5m. I'm dividing 5m to the second into the second by 5m to the second into the second. If you notice, if I take a number or a term and I divide it by itself, that is always equal to 1. So my second part of this is plus 1. This is the factored form. Now, on the previous page, there is a box at the bottom, and the box at the bottom, at the very bottom of the box, said there's a note. You could always check your answer by redoing the distribution and making sure you would end up with what polynomial you started with. Okay, so you can always go back and check. Now, the reason why I point that out specifically on this example is because if you did not write the plus 1 in what remains from undoing that distribution, if I were to multiply it, I would miss that last term, that second term. Okay, so make sure that if your GCF corresponds to one of your terms, it doesn't just disappear. Okay, it doesn't equal 0. Anything divided by itself equals 1. Okay, so for E, we have the situation kind of like we saw earlier where the GCF was kind of obvious. It was in your face. Technically, this is a binomial. We have 7 times quantity x squared plus 1 minus 6y times quantity x squared plus 1. So their GCF is x squared plus 1. So that is what we can undistribute. That's the thing we are going to pull out. And so essentially, I'm dividing this term by x squared plus 1, and I'm dividing this term by x squared plus 1. The x squared plus 1s will cancel, so what will remain will be a 7 minus 6y. Now, your GCF in this case, since it's a binomial, you need to make sure you keep it in parentheses. And for all of these, whatever will remain should also be in parentheses. Okay, go ahead and try C and F on your own. And then when we come back to class next time we come back to class, we will go over them, or you can check your answers. All right. We're going to stop, and this will be part 2 of 6.1. Just again, so it's kind of shorter in chunks. Try C and F on your own, and then I will do part 3, which will be factoring by grouping. Thank you so much.